Hey guys, solving linear equations in 3 variables. So x and y wasn't challenging enough, we decided to throw in a z also. If you were to graph this was where you get the 3D, the third dimension. Here we're only solving algebraically, not graphing. In order to successfully solve these, some of the key points are to stay organized. I mean very organized. Label all of your equations. Use colors if possible. We're going to use the elimination a couple times. Then once you have a variable, you can substitute. Then you do elimination again. And then you finish with substitution. So the actual steps, not difficult as long as you're very organized. Use elimination to solve the system of inequalities. Our first step is going to be you need to number the equations. So I have 3 equations. I'm not going to do anything fancy. We're just going to say this is number 1, number 2, and number 3. It has nothing to do with the actual math. It's simply to stay organized. Then step number 2 is to choose the easiest variable to eliminate. Now some problems are going to be big and complicated, and there's just no easy one. But most of your problems will have something that's a little bit easier. So if I'm looking at the current problem, I have 5, 2, and 3 for the x's. I have 2, 3, and 4 for the y's. But I have 3, the invisible one, and a 2 for the z's. Well, that invisible one there is going to make my life so much easier. Also, I have a negative, positive, negative. That's going to make my life easier. You'll see why in a second. So I've chosen to eliminate the z's. So now I can perform the first elimination problem. I'm going to cancel out a z, so I need the coefficient, the number in front, to be the same, and I need to have opposite signs. Right now it already has opposite signs. I'm happy. In order to make the coefficient the same, I'm going to choose the number 3. I already have a 3 for equation number 1. That means for equation number 2, I have to multiply something to make 3. Well, I know that 3 times the invisible 1 is going to be 3. So I'm going to multiply equation number 2 by 3, and don't forget to distribute all the way through. So now what we're going to do is take equation number 1 and simply rewrite it. So I copied over to equation number 1. Equation number 2 we now call 2 prime. Why? Because this is equation number 2 on the left. Over here, I took equation number 2 and I changed it a little. So that's 2 prime, just indicating that it's equation number 2 but has been changed. Now, don't forget to distribute all the way through, and we combine like terms. 5x and 6x is 11x. Negative 2y and negative 9y is negative 11y. Negative 3z and 3z cancels out, which was the whole point, which is equal to negative 55. Now, because we have created a new 2-variable equation, that is equation number 4. We had 1, 2, 3, and this is 4. Now, there's something kind of cool about this equation. I'm not sure if you noticed, but there's an 11, another 11, and then there's an 11 inside of 55. 11 times 5 is 55. So one cool thing about this is that we can actually reduce by 11. Can't always do that. This just happened to make it easier for us. So I can reduce this side by 11. Whatever I do to one side, I do to the other. That means the 11s are going to cancel out. So our equation 4 prime is going to be 11 divided by 11 is simply x minus y is equal to negative 5. So equation 4 prime, x minus y equals negative 5. Again, we can't always simplify, but if you can, definitely do that. Which takes us to step number 4. Step number 4 is do elimination again. And we do elimination again in order to cancel out the other z. So now I'm down here in equations 2 and 3. I need to cancel out the other z. So if I look at equation 3, I have a negative 2. Equation number 2 has just a regular 1z. So what that means is I need to multiply equation number 2 by 2 in order to get the z's to line up. I'm going to scroll down so I have more room and then clean things up just a little bit. Notice I left that 3 pointing to prime number 2 so I know what I did. That's important just in case we make a mistake. We can follow our work back and see what we did. So now I'm going to multiply equation number 2 by 2. And then I will distribute all the way through. Equation number 3 isn't changing. So I'm going to write it down below. I'm going to multiply through. Now I do elimination like I'm supposed to, but notice I labeled this one 2 double prime, meaning it's from equation 2, but this is the second change that we've made to equation number 2, just to differentiate among them. Now 4x and 3x is 7x minus 2y, 2z and negative 2z cancel out, equals negative 32 and 7 is 25. Can't reduce like I did before, that would be nice, but these aren't too bad. Now this is a new equation, so the new equation is equation number 5 now. Now that I have two variable equations, I can run elimination again and cancel out one of these variables. So I'm going to use 4 prime and I'm going to use 5. Now, if one of these has a different letter than the other, it means that you messed up at the beginning. Remember, you have to cancel out the same letter all the way down. I look at 4 prime and I look at 5, and I can cancel out either the x or the y. Now, if I cancel out the y, it's just smaller numbers, so that's what I'm going to cancel out. In order to get the same number with a different coefficient, I'm going to multiply 4 prime by negative 2. Now I'm going to rewrite it over here. Now that I have them lined up, I just do elimination like normal. 2y minus 2y cancels out. That gives me 5x is equal to, oh, and I forgot my negative sign. Don't forget your negative signs. This was negative 32 plus 7, negative 25, which means I forgot my negative sign over here. 10 take away 25 is negative 15. Always important to keep looking back at your work to look for those mistakes. Hopefully you find them sooner than later. All right, now we can divide both sides by 5, and that gives us x is equal to negative 3. So that was step number 5. Perform elimination with the 2 variable equation. Now, on to step 6. Substitute into the 2 variable equation. So I have x equals 3, and I have 4 prime and 5 prime, which are only x and y. So I can plug them into either of them. I'm going to choose 4 prime because that's the smallest and easiest. So this was 4 prime that I'm using, and I'm going to substitute. So instead of writing x, I'm writing negative 3. We always substitute with parentheses. Negative 3 minus y is equal to negative 5. Negative 3 minus y equals negative 5. The parentheses weren't doing anything. So now, in order to solve for y, I add 3 to the other side. I get negative y is equal to negative 2. So many people stop right here, but it's wrong. You can't have a negative y. Divide both sides by a negative 1 in order to get y is equal to 2 divided by, or negative divided by a negative is a positive 2. Now I have x and y, which brings us to our final step. Okay, second to final step. We have 2 variables. Now we can substitute the 2 variables to find the third variable. So if I go back up to my original 1, 2, and 3, I look at what is the simplest, easiest problem to work with. Well, personally, I think equation number 2 is the simplest, easiest problem to work with. So I'm going to substitute my x and my y into equation number 2. So equation number 2 is 2x minus 3y plus z equals negative 16. I just wanted to rewrite that so we have it in front of us since it's off the screen. Now I'm going to use the x value and the y value that I already solved for. So I have 2 parentheses. The x value was negative 3 minus 3 times the y value was 2 plus z is equal to negative 16. That gives us negative 6 minus 6 plus z is equal to negative 16. Negative 12 plus z is equal to negative 16. Add 12 to the other side, cancels. You get z is equal to negative 4. And we're done, almost. You're not finished. Remember, when you solve systems, you would write an ordered pair. Here, it's not an ordered pair, it's an ordered triple. So the last step is to write your ordered triple. I know, it sounds weird. Call it whatever you want. Go in alphabetical order. X, comma, Y, comma, Z. Our X value was -3, comma. Our Y value is 2, comma, and our Z value is -4. This problem, we just happened to solve X, then Y, then Z. Not always going to happen that way. Sometimes it's going to be in a different order depending on what your step number 2 was. What was the easiest variable to eliminate? Don't get hung up on which one you go with first. Simply do what's ever easiest for you. After that, be neat and organized, and then just keep eliminating things. Once you have nothing left to eliminate, then start substituting.